Oh.
Yeah, he was also retired.
So, we actually are gonna do integration today, where, Daniel just kind of asked, haven't we been doing integration for the past week or whatever it was? And actually, no, we haven't. So, Daniel,
Oh,
Danny,
oh, Spencer asked it too. That's why I was confused. I didn't hear.
Daniel, Danny.
Hi.
I forget you guys have been switching hours. I was like, I've had them all year, but I forget, I haven't had everybody in the same class.
I haven't met you. What's your name?
I'm Donald. Nice to meet you.
Well, they're good, now you guys can call on each other.
Exactly. That's great.
So we haven't been integrating. What we have been doing is finding the answers to the integration problems. So we've been able to find the answers because the area we've been looking at has been like geometric or something we've been able to figure out. Or we've been kind of manipulating the problems to find answers when we were given one to start with. But we haven't actually integrated anything yet. Now, through the notes, I actually don't like the way the notes are set up. They're not bad, but you're probably gonna want your own sheet of paper. You're gonna wanna supplement your notes. So get out a different sheet of paper, which is not on the Chromebook. It's not on the Chromebook. Not Pro. Okay, get another sheet of paper. Not your packet. I'm going to make up notes. So it pretty much just depends how big you write for how many pieces of paper you want. Why do I forget every day who started? Great. You want to answer it, or do you want somebody else to answer? Okay. Do you remember how to do the derivative of x cubed? So just power rule. Perfect. How did you get that 3x squared? Excellent. You multiply by 3. And then you subtract 1 from the power. Okay? And that gave us the answer of 3x squared. Now you guys are probably pretty proficient at derivatives by now. Like, for the most part, you should be able to just find the answers without thinking about it too much. Like we've done power rules so often that I'm hoping you guys are at that stage where it's just automatic. That's the goal, because if it's not automatic, you're gonna have a hard time doing the opposite. Because that's what integration is. Integration is anti-derivatives is the other name for integration. And that's because it's going to be, what the heck? It's gonna be us doing everything opposite of derivatives. So I need to make room here. Okay, well, if our goal is to start with the derivative answer, so if we start with the derivative answer and it's got a power, well, then that obviously was something that the power rule was used on, okay? So our goal is to figure out what it came from. And if we are doing things in reverse, then we have to do things in the reverse order, reverse operations. So rather than subtracting one from the power, this was the second step. Our first step is to add one to the power. You know what, up top I wrote multiply by 3. I mean, it's not wrong, but I just realized that what I should have written was multiply by power. I was trying to write these directions as generic, not specific for this problem. So I should have written multiply by power. And so we're gonna add 1 to the power, which would become cubed. And then we are going to divide by the new power. If I could spell divide correct. So there is a power rule for integration that was discovered by just doing everything the exact opposite order, opposite operations. So 3x squared, I would add 1 to the power to make it cubed. Okay, I wrote cubed. Second step, divide by my power. Well, my power is currently cubed, I'm going to divide by 3. And then this gives us x cubed. So that's the power rule for integration. Like, in and of itself, it's not bad. It's just like power rule for derivatives. Once you know what you're supposed to do, it will go fast. It's not gonna feel natural at first. It's gonna go slow. It's gonna take a little while to have that down. But there are some issues with this. Grady, choose somebody. Yeah, you better know Matt's name, because he gets called on like every day. Okay, Matt. What would be the derivative of x cubed plus 8?
3x squared.
Because, you're correct, because
It's the same thing, but you're taking the power of
derivative of 8 is
0.
0. Okay, so if we had a number being added over here, that would still be the same derivative. So what that means is, we have a whole bunch of equations that could have the same derivative. So if our goal is to go backwards, we have no way of knowing which one it came from. Right? Like, integrating 3x squared, how am I supposed to know if it came from x cubed, or x cubed plus 8, or x cubed plus 2, etc.? Because when you're doing derivatives, sometimes things go away and aren't seen. So what we have to do, anytime you integrate, this is called indefinite integrals, but we'll get there. Anytime you integrate equations, you're going to have to write plus c. And AP makes a big deal about plus c. There are multiple free response questions where if you forget to write plus c, they will remove the points from you. Or, if you write plus c, but get the problem wrong, you'll get a point for writing plus c. So they emphasized to all the teachers that that plus c is really important to them, that you understand it and get where it comes from. That's where it comes from. We have no idea if there was a number there or not. Now this thing has a name. Bless you. This is called the constant of integration. Now, I have no idea why most of the time they write a constant, they put a K. But for the constant of integration, they put a C. Your idea. But we'll go with it. This one makes more sense because it's a C, like we're expecting that.
Wait, so if like on AP test or whatever, you write a different variable, would you get it wrong?
Like if you wrote T cubed,
Like if you, no, like if you wrote like x cubed plus k, let's say.
it's a good question. I have no idea. It's never been brought up. Partially because nobody, I don't think, has ever written it everywhere. You're going to see plus C so often that you'll probably just, like, it'll be automatic without thinking about it, but. I mean, it would make sense that it was to be correct, but I guess I don't know. Don't find out. All right, I don't know, questions about this? This is the general idea of everything we're gonna do today. Does this make sense somewhat? All right. Oh, I know what I forgot. What did I not write over here? I don't know if anybody even noticed it.
Yes.
DX. The whole reason that DX has to be there, let's say we did U substitution for chain rule. If we were doing chain rule, and that was a U, like U substitution, our derivative would have been 3 U squared times the derivative of U. And so this is actually the technically correct derivative. We traditionally write, when we're using x's, we traditionally write 3x squared, but we don't ever write dx because dx is 1. So there is a dx that's present all the time when we do derivatives, but we never write it because for our purposes, the answer was 1. But if you're doing integration, you don't really know what it came from. So you have to put this with it just to be technically correct. And there is going to be a use for that when we get to more difficult problems. That's what the dx is for. I mean, it stands for derivative of x, but it was basically from the chain rule. Matt, somebody over here.
Maggie.
Maggie. Did you call on her because she was on her Chromebook? If so, I appreciate that.
Sure, yeah.
That's fine. Maggie, do you know who you're gonna have to call on next? Who? Good, good, good. No. How long are you gonna be on there? There you go. I got patience, I got time to kill. Okay, Maggie.
Yeah.
What was one of the properties we learned last couple days if there are multiple terms?
Is it look whether it's even or odd?
That part is true, that part I'm not doing right now. That actually won't even help me solve this. Even odd actually only helps if we have numbers on the integral symbol. Okay, does anybody know what I'm trying to ask? What do we do if we've got plus and minus signs? Yes. Okay, so if you've got more than one term, you can separate these. Now, for this problem, I'm going to write them separate, but do know that that's basically done in your head. Like, most people won't ever write them separate. Like, that's not a lot of extra writing. Wait, Daniel? I think I discovered somebody that's far more into something they shouldn't be. Can't get fooled. You haven't even put it away yet. Okay, so how would I split it up, Maggie?
Integral of 3x plus 4 plus the integral of 2x minus the integral of 6.
If you split it up, you have to have a dx on each one of these, because that dx at the end is actually, it's kind of like an assumed dx that's on the whole problem, so it sort of distributes out. So if you split something up, that comes with it. Okay. Maggie, who are you calling on next?
Owen?
Oh, sure. It was either gonna be Owen or Dan, like that was obvious. Owen, how do I go from here? I'm gonna try to do my new power rule for integration.
Alright, so we can start out with 3x to the 4th, so we wanna add 1 to the power.
Good?
So that's 5 and then divide by the new power, so it's 3/5 x to the 5th.
Perfect. And you can write it as 3/5 or 3x5 over 5. Like, they're both correct.
Then next
Wait,
up,
what'd you forget?
plus c.
Good. I'm gonna remind you guys that so many crazy times it's gonna be annoying. And that's because it's super important to remember it.
Is the plus C for every?
I'm getting there. I knew what you were gonna ask, Daniel. You're correct.
So, or you want me to go again?
Sure.
Alright, then for the 2x, add 1 to the power, so 2x squared. But then we divide by 2 since that's our new power, and we now have
Yep.
x squared. And then plus c. Then minus 6, add 1 to the power, we have 6x.
What did you add 1 to?
Hmm?
What did you add 1 to?
The power, so x to the 0 is now x.
Oh, there we go, okay. Good, power rule technically works on a regular number. Most people don't do it, just because it's almost like it's like clogging your head with too much extra stuff. It's easier for most people just to remember that if we took the derivative of 6x, the answer was 6. So if you're integrating a regular number, you're just gonna add a letter onto it. But the power rule absolutely works, nobody ever writes x to the 0.
Plus c.
Good. Okay, so now, I separated all these and I did three separate integrals. And the question is always going to come up, am I supposed to write a plus c for each one of them? Or do I just write once at the end? And the answer is they're exactly the same. Daniel, you're next anyway. What did the plus c stand for?
Constant.
Okay, so it stands for
Some number.
some number that we don't know. If I wrote a c value,
Or it'd still be another C.
if I wrote a c value after every single one of them, it would be correct, and it's not wrong. But it would be annoying to write plus c1, plus c2, plus c3, where if somebody wrote 3 separate numbers, well, nobody would write 3 separate numbers, they would put them together. So if you had 3 separate plain numbers, you would combine them together anyway. And since they stand for a number we don't know, well, we don't know what the number is anyway. So we're just gonna write one combined c at the end. It wouldn't be wrong either way. If you wrote them separately, you would have to have a sub number on them though, to show that they're separate.
In the AP test, will our final answer be the only one that has to include C, or will I have to include C in every single step, or I have to split up
Every single step. Because there are problems where C is part of the problem being used, and you're gonna use C. So, I will also say from experience, that if you only write plus C at the end, you'll forget it. Like, that's usually where everybody's gonna forget it. When I hand you guys your first test on integration, I will give you a reminder to write at the top of the test, add plus C. So that before you turn it in, you can go through and look if you added plus C on the problem or not. Cause I will grade it the same way as AP, I'll mark a problem wrong if you don't write plus C. How did this part go though, like? Oh. I don't know what to think about this. You took out some separate book. You took out your phone. I was about to give you a compliment. I was gonna say, you did that super fast, like, you had that down pretty well already. That's, for some people, that little process is gonna take some time. Other people will get it quickly. Obviously, Owen can multitask. Not that we're gonna do it, but you can. It's good to see that you can. Okay, I'm gonna put some problems up here and I want you guys to just try them. Try to do them on your own. Oh, and simplify them before you give your final answer. Should I put a challenge one as the third one?
Sure.
I like that idea. I mean, like, I'm asking your opinion, but I was gonna do it anyway.
Is it always gonna end up as plus C, or will there be some sort of like weird reverse chain rule or thingamajig that'll make it like plus square root C or something?
Oh, I'll get to that. You wouldn't write square root C because that would just be a different number anyway.
Yeah, so would you just, it would always be.
Plus C absorbs everything.
Okay.
So first you add in your power.
I feel like you guys got this, even the challenge one. I feel like you remember how to do derivatives, you'll remember how to do the integral version. Bless you. Everybody's sneezing today, I don't like this. This is leading and heading towards the weekend where I'm gonna be sick. I don't want that. Although it's supposed to snow a lot, so maybe that's be okay. Let's go with Finn. When you get done with number one, why don't you go write the answer up there? Let's go, oh, Spencer's back. You can do number two. It has nothing to do with the days you were gone. Tegan, you got the challenge one. And if you can't get it, that's fine too. Should I just, maybe I should, do you want me to just ask if anybody wants to do the challenge one?
Yeah.
Oh, it does. All right. Well, if you know how to do it, it's not challenging at all. It's challenging if you're not sure what to do. Whatever you want. Whenever you're done with the problem, you can write it up there. I just wanted to let you guys know ahead of time so you had time to try it. Show your work if you can.
Yep. Trying to get smaller.
If you can't read, because he's writing small, so it's blending together, he changed square root of x into x to the half power. Yep. Like I said, if you knew what to do with it, it's not a challenge problem. It's annoying, but it's not a challenge. Two people can write as well.
Actually, this is not.
Oh, we have to do step by step, right?
Most likely you would just write like most people will write the integration rule, power rule, like as their work. And then the simplified answer is,
Yeah.
so that's kind of the work, I guess, if that's what you're asking. Nope, erase that.
It's just copying what I'm screen.
You aren't. So, I'll explain it when we get there. You're not gonna have the integral symbol anymore.
Oh, sweet.
Finn, how we coming? If you want a hand, I can give you a hand too. Okay.
It works.
Yeah, sort of.
I'm gonna show my work too, or just the answer.
Is your work like what Spencer wrote? So basically, most people for their work are just doing like the power rule for integration, but not simplifying it.
Oh, okay.
So it's not like there's really work to show so much. A lot of it's done in your head. Wait, what? That must be the simplified answer.
Yeah, is that fine or not?
No,
Oh, okay.
it's not wrong, but I wanted to, oh no, Owen, what are you doing? I was so excited to point out what you forgot.
We were reminded.
Did you guys, oh, come on.
See, we're good friends.
We're good friends.
We're good friends like that.
This almost makes up for the Spencer, this almost makes up for the time that you told me to raise my hand.
I didn't, I was the one who told you.
No, I didn't.
What time was that? Which time was that?
What?
Just the time I told him to raise his hand.
Oh, yeah, I remember. I'm trying to think of which time that was. I think you did that a few times.
Sure, you do, I get what you're doing.
And
Okay, I am very happy to see all three of them have plus C now. Owen actually demonstrated very specifically what normally happens. You spend all this brain power trying to figure out how to solve the problem, and it's crazy easy to forget plus C. Like, it's just not something that enters your mind because it's so unimportant. It's just written in the answer. All your brain power is dedicated to try to solve a problem, and it's very easy to forget plus C. And most of the time, / should never happen. You should never have friends telling you to remember to write plus C on your test. So,
Plus C.
well, yeah, I mean, like, that's why I was trying to say, when I hand out the test, I usually have people write that at the top, so they can remember before they turn it in. Okay, so now what Finn wrote, a half divided by 4, which isn't wrong, but I bet that would actually confuse some people in here. So, don't forget that if you add 1 to the power and get 4, instead of dividing by 4, like, dividing by 4 is correct. But I bet most people would prefer to write 1/4. So that if you have a fraction that's there already, putting 1/4 is gonna be easier for you to put everything together rather than dividing by 4. You could write it either way, but I know dividing by 4 would throw some people off. And then this one, I think you just kinda did in your head, divide the 2 divided by the 2. So that's good. This one was perfect. Although the plus C on a separate line is generally not a good plan. Now, I'll go over this one. I'm assuming once you kind of saw how to do it, it immediately triggered, remember doing that for derivatives. For derivatives, you can't do the derivative of a square root, so we change it to a power. So if you can write something as a power, you can use the power rule. So writing it as x to the half and x to the third allows us to do the power rule for integration, just like it would allow us to use power rule for derivatives. And so then you get 2/3 x to the 3 halves, and wait. That's not right. I honestly didn't even actually look at your answer. When you add 1 to 4/3, or when you add 1 to 1/3, it would be 4/3. Maybe you were writing a 4 and thought it looked like a 2. Cause you approached it correct, for sure. Okay, now, today, all I was focused on was power rule. Would you like me to go over how to integrate some other things before we talk about what to do with plus C? Or do you want me to show you how to figure out plus C? Neither. Wow, you are very encouraging. I did not want to do both.
They cancel each other out.
They're not something that should cancel each other out. Yeah, okay.
Why don't we just move on to 6.6?
Well, we're not even close to done with 6.5. Oh, no, the power rule for integration literally made up a half of the last page of your packet. I wanted to dedicate more practice and brain power to power rule before I skipped over everything else. You're gonna dislike this one for one specific reason.
Oh, it's.
Oh, I wasn't talking, I wasn't saying you're gonna dislike it because it's trig.
I've never.
I heard groans, and those groans should not have been just because it's trig.
Well, they are.
They are.
But you don't have to do anything for trig derivatives.
The weird.
It's simply the
rule.
tangent that I hate.
It's the
most.
weird
I don't-
rule.
You just have to memorize
I don't
them.
remember.
That's
it.
the problem.
Alright,
I blocked
so-
it out of my head.
Did you guys
Can't-
probably memorize that? Why does everybody go on their phones? That's so annoying. It's similar, it's similar to if I stopped teaching to like check out my notifications. And or, oh, somebody wrote something, I better check that.
You had to check the package.
It's not coming here to school. If it's coming to my house, then there's nothing I can do about it anyway. That is a good point. Maybe my flight instructor would need to tell me it's too windy to fly later in the day, which would affect me during class. Most of you, I apologize.
No, I like the jokes.
I think,
Is there a difference between D and X and like D any other letter or no?
that just means that we're using X.
Oh.
So, okay, cool.
Correct. There is no difference. If we were using a Y instead of an X, then you would write D, D, Y, and then a Y. My guess is you guys memorized these as the derivative of sine is normal, and the derivative of cosine is opposite.
Yeah.
Is that probably right?
Yeah.
Which is 100% correct. Derivative of tangent is secant squared. I'm not even gonna go over the other three, but I could. Here's where it gets annoying. It's the exact opposite for integration, right? Like, it makes sense, like you would expect it to be the exact opposite. What should I write next to the blue one? Should I write the integral of tangent? This is where a lot of people get messed up. I'll just do sine and cosine for now. I'm gonna get everybody else flip down. Integral of sine is going to be negative cosine. Integral of cosine is
Sine.
positive sine. And, oh, and I did them wrong because
There's no C.
there's no plus C. Even trig, I mean, the trig ones need a plus C as well, because we have no idea if there was a number there. I mean, this makes sense if you think about it. If you take the derivative of the answer, it should become that. So derivative of sine is cosine. the derivative of negative cosine would be the opposite of negative sine. I mean, it makes sense, but most everybody just memorizes this. So, the derivative of sine is cosine. Everybody's got that down. I'm sure that's the one everybody has down. What you're gonna need to memorize is that integration is backwards. So the integration of sine is the opposite one. Integration of cosine is the easy one. That's kinda how my head remembers it. Easy, hard, but even though they're not. So here's the number one mistake everybody's gonna make. And I get why. We have one for sine, for cosine. You're gonna be expecting this to be tangent.
Is this like?
It's not.
Tan over secant or something?
This answer is actually horrendous. This answer is like the natural log of, a multiple things in an absolute value plus c.
Oh, great.
Yeah, so integration is backwards of derivatives. So technically, if we took the derivative of the answer, it should be tangent. But that's not how it goes. What we are gonna focus on is these have to be the derivative answers.
Is it like the reverse derivative condition?
Don't talk about that yet. You don't wanna go there yet. I know what you're saying. The integral of secant squared is gonna be tangent, because if I did the derivative of tangent, I'd get secant squared. So when you're doing integration, these are the derivative answers. Yeah, I mean, it 100% feels like we are gonna have to memorize sine, cosine, tangent, like the 6, but it's not true at all. Integration only works if you can take the derivative of the answer to get that. So these have to be perfect derivative answers already. Okay. Here's what I'll give you guys about 10 minutes to do, because we get done at 27 today. Yeah. Okay, so I'm gonna give you 10 minutes. What I would like you to do is on your notes, write down the other 3 trig derivatives. Do you guys remember the trick to doing the derivatives? Oh, jeez. Well, anybody want to look them up? And then write down the other 3 integrals that should correspond with those. Remember, this has to be the derivative answer. So you're not gonna do the integral of cosecant, you're not gonna do the integral of secant. Those are actually way more difficult than they would expect to be. So these 3 are going to be the answers from the 3 derivatives. Those are gonna make up 80% of all the derivatives we do. Power rule and trig. Oh, did I say derivatives? Those are gonna make up 80% of all the integrals we do. Power rule and trig. So, I feel like you guys kind of already have the power rule down, which makes sense, we did it a lot. These are the ones you're gonna have to get better at. So I want you to come up with, are they in the packet already? Or are you just doing homework?
Homework.
Okay, I didn't think they were in the packet yet.
They are.
I'm sure they're in there somewhere, yeah. Don't use the packet. Try to figure out the derivatives on, get out of there. I have a formula sheet that I'm going to get you. It doesn't do any good if you just memorize everything, because that means you'll forget things. If you learn how something works, then for some reason your brain remembers it a lot better. If you just memorize facts, then your brain will forget facts. Just think of 8-bush. Think how much you had to memorize for that. You think how much of that would you recall right now? Well, yeah, every year is a different grade.
I never wanted.
English is horrible.
It's a lot of facts, right? And some people love facts. But most people forget facts pretty easily. So, if we try to do everything in calc as facts, you're gonna forget it. Okay, I wasn't, that was my fault, I got you off task here.
You have a book?
I put in a minute.
No, no, no.